Look, we're all seeing this AI revolution happen in real time, right? It's totally changing our digital lives. But there's this massive, invisible wall that's separating all that incredible intelligence from the physical world all around us. In this explainer, we're going to talk about that wall and the wild new idea that might just smash it to pieces. Seriously, think about this for a second. We have AI that can write poetry that's genuinely moving, pass medical board exams, and create unbelievable art. But then, go and ask that same super genius AI to do something a toddler can do, like just flip a light switch. It can't. It's totally powerless. And this isn't some trick question. It's right at the heart of one of the biggest challenges in tech today.
And yeah, this actually has a name. It's called the AI paradox. It's that huge, frustrating gap between what an AI can think and what it can actually do in the real world. And figuring out this paradox is the absolute first step to solving it.
I mean, just look at this comparison. The contrast is almost ridiculous, isn't it? On one side, you have these godlike abilities in the digital world, and on the other, complete incompetence in the physical one. An AI can design a brilliant, hyper-efficient energy grid for a city, but it can't actually tell the transformers what to do. It's basically a genius mind trapped in a box with no hands to do anything.
So what's the deal? Why is there this massive disconnect? Is the AI just not smart enough for the real world? No, that's not it at all. The problem isn't the AI's intelligence. It's the messy, complicated world we're asking it to plug into.
The real culprit here is something called hardware fragmentation. Think about it. Our physical world is just a chaotic mess of devices. We have literally tens of billions of sensors, motors, switches, you name it. But it's like a digital Tower of Babel. They all speak different languages, run on different operating systems, and have their own unique set of rules. There's no universal translator.
Just to give you a concrete example, look at these two super popular operating systems for IoT devices. At their core, they're just built differently. How they manage memory, how they handle security, everything. One isn't better than the other, they're just for different jobs. And this is just two of them. Now, multiply that complexity by thousands of other hardware platforms, and you start to see why an AI can't just plug in and start driving.
And this right here, this quote just hits the nail on the head. It perfectly captures that real-world frustration. A factory manager can ask an AI, "Hey, how do I make my production line faster?" and get a brilliant data-backed plan. But to actually do it, they need a whole team of specialized engineers to go and manually reprogram every single machine one by one. The AI's genius idea just sits there on a screen, completely useless.
So let's be super clear about this. We don't have an intelligence problem. We have a translation problem. There's just no simple universal bridge that can take what the AI wants to do, its high-level goal, and translate that into a low-level command that a simple physical device can actually understand and act on.
Okay, so we've got a huge problem. But what if? What if we could build that bridge? What if we could create a universal language for the physical world? You know, it actually wouldn't be the first time a single language came along and changed everything.
We've seen this movie before. Back in the 70s and 80s, databases were a lot like IoT devices are today. They were fragmented, chaotic, and only the top experts could get anything out of them. Then SQL came along, a simple, powerful language that let anyone ask for data, and boom, the information age was born. So the big question is, could this new thing, AIoT logic, be the SQL for the physical world? And when you dig into it, the comparison is kind of mind-blowing. SQL is what we call declarative. You just say what you want, not the step-by-step of how to get it. AIoT logic is the same idea. You just say, turn the light on when it gets hot, not all the complex code behind it. SQL provides abstraction. The same command works on any database. AIoT logic is aiming for the same thing, but for any piece of hardware. It's all about making it simple and standard. And look, this isn't just a fun little comparison. People in the know see this as a prediction, a roadmap. The idea is that if you can create a simple, powerful, and universal language for physical devices, you're not just solving a technical problem. You're kicking off a whole new age of automation.
All right, enough with the theory. That all sounds great, but what does this actually look like in practice? How can one simple language possibly handle complex, real-world commands? Let's dive in and see it in action.
So here's a set of instructions. To you and me, it seems pretty straightforward. But for a computer, this is actually a huge headache. You've got nested logic, and if this, then do that, but only if this other thing is true, and a bunch of different outcomes. Normally, to program this, you need a whole chunk of code, and you'd have to be an expert in that specific machine's language.
Now get ready for this. This is that entire set of instructions written in AIoT logic. That's it. One single, compact line. It looks a little weird, but it's pure logic. The brackets create those if-then conditions, and the letters and numbers are just codes for specific actions, like I for an input sensor or D for a motor. It packs that whole complex command into something a machine, and especially an AI, can generate and understand perfectly.
So, how does this new kid on the block stack up against the old ways of doing things? Well, you can see for yourself. Other tools are okay at some things, but none of them get 5 stars across the board like AIoT logic does. They're either too clunky for an AI to write, too long and complicated, or you can't just easily send the command over the web. AIoT logic is really in a class of its own here.
So what makes it so special? It really boils down to 3 things. First, it's almost a perfect one-to-one translation from plain English to code. AIs love that. Second, it's so compact. You can embed an entire command right into a URL, a simple web link. And third, it's incredibly dense. You can communicate a really complex idea in a very short, unambiguous way.
Okay, so a new language is cool for us tech nerds, but what does it mean for everyone else? Well, if this works, it's not just a cool trick. This could be a game changer that completely reshapes how we interact with the world around us and kicks off a new wave of smart automation.
How big of a game changer? How about $2 trillion? That's the estimated amount of value, of market potential, that's basically locked up right now because AI can't touch the physical world. Industries like manufacturing, agriculture, smart cities, they're all just waiting for AI to go from analyzing to actually acting. This language could be the key that unlocks it all.
And here's what that looks like in action. It's a beautiful, elegant 5-step loop. Step 1, you just say what you want in normal English. Step 2, an AI instantly translates your words into AIoT logic. Step 3, that command gets sent to the device. Step 4, the device does the thing. And Step 5, the magic part, the sensors on that device send data back, creating a feedback loop so the AI can learn and make adjustments on the fly. It's a fully autonomous, intelligent system.
And think about this. Just like SQL created brand new careers that didn't exist before, like database administrators, a universal IoT language could do the exact same thing. You could see whole new industries pop up. IoT logic designers who orchestrate huge physical systems with language, or a boom in conversational IoT, where we literally just talk to our factories and homes to manage them.
And that's really what this all comes down to. The goal here is to stop thinking of AI as just a brain we can ask questions to, and to start thinking of it as an agent, something that can actually do things for us in the real world. A bridge like AIoT logic could finally let AI out of its digital prison, and when that happens, the true age of automation will finally begin.